everyone, my name is Atinoke Fasea. Welcome to InterswitchSPAK prep class. I'll be your chemistry tutor and we'll be looking at nature of matter. Now, you already know what matter is. Matter is anything that has mass, occupies space, and we have a lot of examples of matter. You are a matter, I'm a matter, provided we are occupying space, and we have mass. We are all matter. The person beside you is matter. The table you are sitting, you are putting your book on is matter. Your chair is matter, and it has both physical and chemical properties. The common physical properties include the boiling points. Physical properties are things you can observe, things you can see, things you can notice. While chemical properties are things that you cannot see. You cannot really notice, but there are reactions going on that you don't know. And states of matter. We have states of matter, which are three. We have solid, liquid, and we have gases. And I guess physics people will tell you that they have a new one. Okay, find out for me the new one. Okay, we have three physical states, and that can change based on temperature. Temperature and pressure can affect it. A very good example is when you have your ice block turn into water and also steam. I expect that you jot down things that you might need later. By the time we go to questions, and you'll be able to answer the little questions I have for you after this video. Now we have differences between solid, liquid, and gases. I know you've done this before. Let's quickly remind ourselves. For volume, it has a fixed volume, which is solid. Liquid has a fixed volume as well. And gas, no fixed volume, expands to fill the container. We have density. For solid, it is high, liquid, moderate to high, and the gas, we have low. For example, if you have your ice block, let's use our ice block for solid, and let's try and use our water for liquid, and gas, of course, we can use our water vapor for gaseous example. Now, for shape, you notice that the ice block has a definite shape, but for water, it flows. It takes the shape of the container, and for gas, it flows generally. For fluidity, it does not flow, and for liquid, generally flows easily. Then for gas, it flows easily. Pressure, there's no way you can press down your ice block. It will not be affected. Pressure will not affect it. But for liquid, you can slightly compress your water. You can try to add more until it will not take anyone. And for gas, you can continue to compress until it is filled up. Differences between physical and chemical changes. Physical changes are changes that cannot be reversed, while chemical changes are changes that are easily reversible. They can easily be reversible. For physical changes, new substances are not formed. Of course, you have examples of physical changes. New substances are not formed. Freezing of an ice cream. Does it give you a new substance? No, it doesn't give new substances. But for chemical change, even burning, the moment you burn substance, something else has been formed. That's why substances are formed during chemical changes. For physical change, there's no change in mass, and for chemical change, there's a change in mass. For physical change, does not involve great heat change, except latent heat of fusion or evaporation. And for chemical change, it involves great heat change when explosion. Now, already you know the definition of elements, compounds, and mixtures. That's the major aspect of chemistry that you first have to learn by the time you start doing chemistry. Elements are substances that cannot be easily broken down into simpler substances. Examples of elements, we have hydrogen, carbon, sulfur. We have a lot of elements, silicon, magnesium. Then we have compounds. Compounds are pure substances made from two or more elements. chemically combine together. You know, when your hydrogen and oxygen react, they give you water. Hydrogen and chlorine react to give you hydrogen chloride. Dissolves in water, it also gives you hydrochloric acid. The mixtures contain two or more constituents which can easily be separated by physical methods. A very good example is your rice and beans is a mixture. Your garri and water is a mixture. All these things are, you can separate it. You know, you can definitely separate your garri and beans. No, let me say rice and beans. You can definitely separate it. You pick it, you separate your rice from your beans. You pick it. So mixtures can be separated, and that will take us to separating techniques, because we know that it's only mixtures that separating techniques can work for. Now, for separation techniques, there are some factors to be considered. There are some factors to be considered why you need to undergo a particular technique for separation. One, the size of the particle. The size of particles depends. If you have big size, small size, then you have to look at sieving, or hand picking. So it depends on the particles. Then you have difference in solubility. Is one soluble? Is one not soluble? You have some separating techniques to be used. A very good example is your filtration. Then you have boiling points or volatilities. Then for boiling points, a very good example is fractional distillation, or fractional distillation, or even simple distillation. Then you have your magnetic properties. It depends. Maybe some substances are magnetic in nature, so you can use magnetism to separate these substances. Then density, it also depends on how dense the substances are. There are some that are lighter than the other, and the separating phenomenon can be used to separate substances that are less dense or more dense than each other. Then you have rate of movement on absorbing medium. That major factor is being considered when you're looking at chromatography. Chromatography is used in separating colors, and also to know if substances are pure or not pure. Now let's look at atom. Atom is the smallest particle of an element which can take part in a chemical reaction or exist alone and still possess the chemical properties of that element. All atoms are inside elements. Atoms are inside elements. So that means all elements has atom. Now, this is like a diagram of atom. Inside an atom, we have three subatomic particles. We have protons, which are positively charged. We have electrons, which are negatively charged and orbit around the atom. We have the center to be nucleus. And inside this nucleus, we have the protons and the neutrons. The protons and the neutrons. Neutrons do not have any charge. Protons do not have any charge. So this particular diagram exists in all atoms. It exists in all elements. So it depends on the number of electrons. Number of electrons is equivalent to the proton number, which is also equivalent to atomic number. And the addition of proton and neutron will give you the mass number of that element. Ion is a charged particle formed from atom or group of atoms by loss or gain of electrons. We have two types. We have the positive, which is a cation, and we have the negative, which is an anion. A positively charged ion contains more protons than electrons, while a negatively charged ion contains more electrons than protons. Molecule is composed of two or more atoms of the same or different element, except that of a metal or noble gas. The number of atoms in each molecule of an atom is called atomicity. We have some elements that are monoatomic, that means they have one atom. We have diatomic, that means they have two atoms. And we have triatomic, and we have polyatomic. And when you write them in reactions, remember that you have to consider the atomicity. So if you're writing nitrogen in a reaction, you must put H2. H2 plus Cl2 to give HCl, because hydrogen and chlorine are diatomic in nature. Valency. Valency is a combining power that an atom has. When elements, atoms go into reactions, they are not the one going into reactions. It's the electrons that are going into reactions. And when electrons go into reaction, there is a power that they must have. This power is known as valency. Now, each element has valency. Valency are formed based on the electronic configuration. Now, this table has analyzed the different valency for each element. We have those that have 0, we have helium, neon, argon. For those that have 1, hydrogen, lithium, sodium, potassium, gold, bromine, iodine, chlorine, and silver gold. The silver, this is gold. Then we have beryllium, oxygen, magnesium, calcium, zinc, barium that have valency of 2. We have boron and aluminium, even chromium that have valency of 3. Then we have 4, silicon. Then we have some elements or atoms that have variable valencies. Variable valency is that they can use either this or this to go into reaction. For carbon, we have 2 or 4. Nitrogen can exist as 1, 2, 3, 4, or 5. Phosphorus, 3 or 5. Sulfur can exist as 2, 4, or 6. Iron can exist as 2 or 3. Nickel, 2 or 4. Copper, we have copper 1, we have copper 2, we have mercury 1, we have mercury 2. We have tin 2, tin 4, lead 2, lead 4, manganese 2, 4, or 7. Then chromium 2, apart from the fact, can be 3, it can also be 6. And we have cobalt, which can be 2 or 3. These are basically the elements that we see or we engage ourselves in on daily. Daily, we engage ourselves on these elements or atoms, and that is why you must familiarize yourselves with these valencies for you to write reactions comfortably. Then let's look at radicals. It's a group of atoms of 2 or more elements carrying a positive or negative charge. Examples of some radicals and their charges. These are charges, radicals that you must familiarize yourself with. At this stage, they will wake you up and you are expected to give me the formula for heptazole dichromate 7-ion at Cl2O72 minus. So this reacts with atoms or other elements, and compounds are being formed. For example, if you have calcium reacting with tetrahydrophosphate 5-ion, calcium is Ca2 plus. This is a PO4 minus. By the time they exchange valencies, you see the formula to be Ca3 bracket PO4 close bracket 2, because that is calcium tetrahydrophosphate 5-ion. I'm sure you understand the swapping of valencies and how compounds are being formed. Now, this is electronic configuration of elements, and they go in increasing energy. So you have, can you have your pen and start writing? You have for all the elements on the periodic table. So you have 1s2, 2s2, followed by 3s2, 3p, 2p, 1s2, 2s2, 2p6, 3s2. You write it in that order. Just write it in that order, and you'll be able to write for all elements on the periodic table. So for example, if you want to write for calcium, which is atomic number is 20, what are you expected to write? Let me give you 1 second for you to put it in your thoughts. Okay, so it should be 1s2, 2s2, 2p6, 3s2, 3s2, okay, 3p6, then 4s2. That will be 20. quickly look at gas laws. Gas laws. I'm sure you've done gas laws. So yeah, let's revisit gas laws. We have Boyle's law, we have Charles' law, Avogadro's law, ideal gas equation, we have Dalton's law of partial pressure, we have Graham's law of diffusion, we also have Gay-Lussac's law of combining volume. But we'll quickly look at few so we can remind ourselves. So let's look at Boyle's law. It states that the volume of a given fixed mass of gas is inversely proportional to its pressure, provided the temperature is kept or remain constant. As volume is decreasing, what is happening to your pressure? Your pressure is decreasing. And the formula is P1 V1 is equal to P2 V2. We have Charles' law. For Charles' law, it said that the volume of a given mass of gas is directly proportional to its absolute temperature. The most important part of that law is the absolute temperature in Kelvin, provided pressure is kept or remain constant. Charles' law is V1 over T1 equal to V2 over T2. And as your volume is increasing your temperature is also increasing. As volume is increasing, your temperature is also increasing. Now time for questions. Yeah, so let's do this. You get your pen, you get your writing material. I'll give you the question, I'll give you a few seconds to get the answer. Then by the time I show you the answer, you mark and let's see how far you can go. Is that okay? Are you ready? Time, question time. Okay, quickly get your pen, your writing material. Waiting. Okay, let's start. Now, there's no option, so I expect that you'll be able to get it. A pure substance that is composed of two elements in a fixed and definite proportion is called you see your answer? Okay, so let's see the answer. Compound. Now you can mark. Did you get it? Yes or no? Okay. Moving on to the next question, and that is how we'll be treating each of the questions and see if you can remember or not. Following are examples of chemical change, except we've looked at chemical change and physical changes. We've looked at differences between physical and chemical change. So what do you think the answer is? Let's see the answer. Freezing of ice cream. Yes, this is a physical change. Others are chemical changes. Rusting of iron, fermentation of substances, combustion of substances are all chemical changes. They are all chemical changes. A change which involves formation of new substances is known as. I'm expecting you to write your answer down. Okay. Of new substances is known as. So let's see the answer. Chemical change. Chemical change is when new substances are formed. In physical change, no new substances is being formed. Chemical change are irreversible, while physical changes are reversible. The state of matter which retains its volume but has no definite shape is. We have three states of matter. We have solid, liquid, gas. So which of these states of matter retain its volume but has no definite shape? The answer is liquid. Liquid retains its volume but has no definite shape. Substances that have no fixed compositions are called dash. Heterogeneous mixtures or homogeneous mixtures. So what are they called? Heterogeneous or homogeneous mixtures. Okay, I'm waiting for you to pick your answer. And what did you pick? Did you get the answer? Let's see. They are heterogeneous. No fixed compositions. No fixed compositions. They are heterogeneous mixtures. Which of the following is a poor conductor of electricity? Is a poor conductor of electricity. One major thing you should know is that metals are good conductors of electricity, while non-metals are poor conductors of electricity. So your answer should be chlorine. Your answer should be chlorine. Chlorine is a non-metal and is a poor conductor of electricity. The following are examples of a mixture, except, so they are mixtures, but one is not. One is not. Air, bronze, brass, sugar. So what is your answer? I guess you good. The answer is sugar. Sugar is a compound. Sugar is a compound. Others are mixtures. Air is a mixture of gases. Bronze, brass are a mixture of metals. The liquid which passes through the filter paper during filtration is called. The liquid which passes through the filter paper during filtration is called filtrate. That's the answer. Filtrate is the answer. Now let's quickly look at filtration. This is filtration, and the filtrate passes through the filter paper. The residue stays on the filter paper. The residue stays on the filter paper. So this is one of the separation techniques that has to do with solubility. So the soluble substance goes, or soluble salt or soluble one passes through the filter paper, while the insoluble stays on the residue. The insoluble stays on the residue. The method used to separate liquid and denser solid particles, which separate into two distinct layers on standing, is referred to as. Decantation is the answer. Did you get it? The answer is decantation. Okay, let's look at it. So this is how decantation takes place. The denser one stays at the base of the container of the beaker, while the lighter one is being decanted. Lighter one is being decanted. Most times I use the example of when you drink garri and you see that you pour water inside the garri and you realize that there's some dirt particles that you don't like on floats on the garri. What you do is that you try to decantate the garri, you just pour it away, pour the dirt away, then you now add more water so that you can have your garri, then you drink your garri. Except you don't drink garri, maybe you're not in Nigeria, but for those of us that we drink garri, most times we do that. Which of these separation techniques is best suitable for separating components of universal indicator solution? Yes, you realize that we mentioned that one of these techniques is used to separate colors, and the answer should be chromatography. Chromatography is used in separating colors, anything that has to do with colors, be it chlorophyll in leaves, be it ink. Chromatography is used to separate the different colors in an ink. Which of the following can be used to ascertain the purity of a solid sample? Which of the following can be used to ascertain the purity of a solid sample? The answer is melting point. Melting point is used to ascertain the purity of a solid sample. Not only melting point that can be used, we have fixed or definite boiling point. Boiling point too can be used to ascertain the purity of solid sample. We have density. Density can also be used to ascertain the purity of solid sample. The ability to produce spots on paper chromatography too can be used. So all impure substances will lack all their aforementioned properties. All their aforementioned properties. So if your substances has fixed melting, boiling point, fixed fixed or definite density, ability to produce spots on paper chromatography, you know that the substance is pure. But the moment the substance do not have any of the aforementioned property, you realize that it's impure. Which of the following factors is not considered in choosing appropriate separation technique? Is not considered in choosing appropriate separation techniques. Earlier in the class, you realized that we look at some factors that affect, some factors to be considered when picking a particular separation technique. So which one is not considered when picking a particular separating technique? The answer is molar mass. Molar mass does not affect or is not considered in picking a particular separating technique. We have the size of particles to be considered, we have difference in solubility, we have difference in boiling point, we have magnetic properties, we have densities, and we have rates of movement on absorbing medium. So molar mass does not affect or is not considered in choosing appropriate separation technique. The following are radicals except we said radicals are a group of ions or atoms that go into reactions on their own. I gave a table of radicals that you know. So which one is not a radical? If you look at the answer, it's not far-fetched. The answer is water. Water is the only one that is not a radical here. So can we name the radicals one after the other? This is H3O plus, this is hydrozonium ion, this is SO4 2 minus, this is tetraazosulfate 6 ion, and the last one is ammonium ion. All these are called radicals, and they are formed using coordinate covalent bond, which is also known as a dative bond. Oh, I love this question. It's a simple question, so I hope that everybody will be able to get it. The release of harmful substances into the environment by natural forces is called pollution. Yes, the answer is pollution. And we have types of pollution. We have land, we have air, we have water, we even have noise pollution. I know this is a simple question, so I expect all my students to be able to get this. Which of the following is an amphoteric oxide? Amphoteric oxides are oxides that react with acid and also react with base, or you can say that they have acidic properties and they also have basic properties. So which one is an amphoteric oxide? In the options below, We have zinc oxide, we have sodium oxide, we have carbon 2 oxide, and we have sulfur 4 oxide. The answer is zinc oxide. I hope you got it. The answer is zinc oxide. So zinc oxide is an amphoteric oxide. Other examples of amphoteric oxides is aluminium oxide, Al2O3, and we also have PbO as well. Now we have types of bazites. I know I've mentioned it once. Acidic is sulfur 4 oxide, sulfur trioxide, carbon 4 oxide, even phosphorus oxide, that's P4O10. All these are phosphorus 5. All these are acidic oxides. Then we have basic: potassium oxide, sodium oxide, magnesium oxide, copper 2 oxide, and calcium oxide are basic oxide. Then we have neutral. Neutral are neither acidic nor basic. We have carbon 2, we have water, and we have N2O. N2O. They are amphoteric, like I said, can react with both acid and base, and can also behave as an acidic or a basic oxide. The smallest particle of a substance that is capable of independent existence and still retains the chemical property of that substance is called, okay, have you written your answer? The answer is molecule. Molecule is the smallest particle of a substance that is capable of independent existence and still retains the chemical properties of that substance. And we have some elements that are diatomic molecule, monoatomic molecule, we have triatomic molecule, and we even have polyatomic molecule. The maximum number of electrons that can be accommodated in Helm shell is 18. That's the answer, is 18. Now let's quickly look at it. Now, this is the shell. The first shell, this is the nucleus. Then the first shell, which is a K shell, can take 2. The next shell, which is the L shell, can take 8. The next shell is the M shell that can take 18, and N can take 32. So we have the first energy level, the second energy level, the third energy level, and the fourth energy level. So you can see M we take or we occupy 18 electrons. Which quantum number represents the energy level of the shells? Which quantum number represents the energy level of the shells? We have A, principal, B, subsidiary or azimuthal, then we have C, magnetic, then D, spin. So what's the answer? Principal. That's the answer, principal. The principal quantum number determines the energy level and distance from the nucleus. It determines the energy level and distance from the nucleus, while the subsidiary, or you call the azimuthal quantum number, which is denoted by L, determines the number of energy sublevels in an energy level. Then the principal quantum number is denoted by N. Then while the magnetic quantum number, which is denoted by M, determines the number of orbitals in a subshell. It determines the number of orbitals in a subshell. While the spin quantum number S describes the spin of an electron in an orbital. It describes the spin of an electron in an orbital. So these are the 4 quantum number which represent, that has to do with the energy level. That has to do with the energy level. The quantum number which divides shells into orbitals is called, we've already mentioned something similar to it. So what's the quantum number which divides shells into orbitals? What is it called? The answer should be, let me give you a few seconds to revisit it and see if you can get your answer right. Okay, so the answer is azimuthal, which is also known as subsidiary. That's the answer. Okay, so let's revisit it again. The principal quantum number n determines the energy level and distance from the nucleus, while the subsidiary azimuthal quantum number L determines the number of energy sublevels and energy level. Then the magnetic quantum number M determines the number of orbitals in the subshell, while the spin quantum number describes the spin of an electron in an orbital. What is the mass number of an element if its atom contains 15 protons, 16 neutrons, and 15 electrons? What's the mass number of an element if its atom contains 15 protons, 16 neutrons, and 15 electrons? Can you do little marks there so that you can get your answer? So the answer is 31. The answer is 31. And what happens? Now, for you to get the mass number is the addition of the protons and the neutrons present in the nucleus of that element. So in this question, the proton is 15 and the neutron is 16. So 15 plus 16 will give us 31. That's the mass number. That's the mass number. And most times for atoms, the proton is also the same value as the electron number. The proton number is the same value with the electron number. Okay, so what's the IUPAC name of NO3 minus? The IUPAC name of NO3 minus. Okay, the answer is triazonitrate 5 ion. Triazonitrate 5 ion. So by the time you react this to a cation, then you have, for example, if you react with Al3 plus, then you have aluminium triazonitrate 5. And if it's copper, you react it with that Cu2 plus, it gives you copper 2 triazonitrate 5. The temperature at which a solid changes into a liquid is called, the temperature at which a solid changes into a liquid is called melting point. That's the answer. The answer is known as melting point. Melting point is the temperature at which a solid changes into a liquid. Solid changes into a liquid. So by the time you are looking at liquid to solid, what will it be called? Liquid to solid, that will be freezing. That will be freezing point. Liquid to solid. And liquid to vapor, that will be boiling. Liquid to vapor will be boiling. If X is a group 3 element, its oxide will be represented as, is it XO, X2O, S2O3 or XO3. So what's the answer? The answer is S2O3. S2O3. A very good example of group 3 element is aluminium, and aluminium is Al3 plus. All group 3 elements are expected to have a charge of plus 3, and by the time they react with oxide, which oxygen, which is going to be the oxide is when oxygen reacts with an element. Now, so when oxygen reacts with an element, they are called oxide. So you have oxygen to be 2. So by the time they swap valencies 2 and 3, you have S2O3. So if your X is aluminium, then it gives you aluminium oxide. That's Al2O3. If your X is chromium, that will be Cl2O3. If your hex is even ion 3, then it will be Fe2O3. So the right answer is S2O3. The electronic configuration 1s2, 2s2, 2p6, 3s2 is that of a dash group. Okay, so our answer should be group 2. And how do you do that? How do you do that? Looking at the electronic configuration shows a whole lot of things to us. One, because it ends with S, it's telling us that this particular element is on the S block. Because it ends with S, it's telling us that this particular element is on the S block. Now, how do you know the elements? You add the 2 plus 2 plus 6 plus 2. That gives us 12. So that means the elements we are talking about here is magnesium, and the atomic number is 12. Atomic number 12, the element is magnesium, and I said S, it ends with S, which shows that it's on the S block, and the S block is on the right hand side, on the left hand side of the periodic table. The first two columns on the left hand side of the periodic table. Now these last two, this superscript 2 shows to us that it's on group 2. So it's on the second group in the periodic table, and that is the valency. It's carrying a valency of 2 as well. So that is why we know that it's in group 2 of the periodic table. The positively charged particle in an atom is the positively charged particle in an atom is a proton. We have 3 subatomic particles in an atom. The positive one is known as proton, while the negative one is known as electron, and the one that do not have charge is known as neutron. The proton and the neutrons are collectively called nucleon. The protons and neutrons are collectively called nucleon. Which of the following compound is ionic? Which of the following compound is ionic? Ionic is when metals transfer their valence electron to non-metal. So we have types of bonding. We have ionic, also known as electrovalent. We have covalent. We have dative, and we have metallic bonding. Excuse me. And we have metallic bonding. So the answer is calcium chloride. All others are covalent. Water is covalent. Hydrogen chloride is covalent. Sulfur 4 oxide is covalent. This is the only one that is ionic. There's a transfer of electron from calcium, which is a metal, to chlorine, which is non-metal. Which of the following is an acidic salt? We have types of salts. We have normal salt, we have acidic salt, we have basic salt, we have complex salt, and we have double salt. Now, for this, which one is an acidic salt? Let's see the answer before we look at the other options. The answer is sodium hydrogen tetrahydrosulfate 6. Yes, it has not replaced all the hydrogen molecule, so it can still react further to give you Na2SO4. So this is an acidic oxide, acidic salt, sorry. Sodium chloride is a normal salt from a strong acid and a strong base. So this is a normal salt or a neutral salt. The same thing goes for sodium tetrahydrosulfate 6. Sodium is from a strong base, and sulfur 4 SO4 2- is also from a strong acid. So both will give a normal salt or a neutral salt. The same goes for calcium chloride. Calcium chloride is from a strong base, and chlorine, the hydrochloric acid is also strong. So these also give a normal salt or neutral salt. So the answer here is NaHSO4. Which of the following is not a greenhouse gas? Yes, which of the following is not a greenhouse gas? Greenhouse gases are gases that causes global warming. They cause global warming to us, and the effect of global warming, it leads to famine, skin diseases, polar ice melting, and these are effects of global warming. So the answer to this should be should be hydrogen. Hydrogen is not a greenhouse gas. Methane and carbon 4 oxide are greenhouse gases. Methane and carbon 4 are greenhouse gases. The color of methyl range in acidic solution is, we have indicators and we have types of indicators. We have methyl orange, phenolphthalein, methyl red, bromothymol blue. We have different types of methyl indicators. We have the litmus paper, litmus solution as well. There are types of indicators. So what's the color of methyl orange in acidic solution? The answer is red. We have red. Now let's quickly look at the color changes. For blue litmus solution in acid solution, we have it's red. Then in a basic solution, the color does not change because it's blue. And in neutral solution, no change in color. Then for red litmus solution, we have no change in color because it's red. In acidic is red. It will not change. While in basic, red turns to blue. Then neutral, no change in color. Therefore, methyl orange, in acid solution, it is red. In basic solution, it is yellow, and neutral solution is orange. Then we have phenolphthalein, which is also an indicator, which is used in titration of weak acid and a strong base. Weak acid and a strong base. In acid solution, is colorless. In basic solution, it is red, and in neutral solution, it is colorless. Methyl orange is can be used in strong strong acid and also strong base. We also have methyl red. Methyl red can also be used in a weak base and strong acid. But there is no indicator to titrate when you are titrating a weak acid and a weak base. Elements with the same atomic number but different mass number are considered to be isotopes. Isotopes are elements with the same atomic number but different mass numbers. So isotopy is a phenomenon or occurrence whereby we have elements with the same, we have two or more elements with the same atomic number but different mass number. And a very good example of isotope is hydrogen. It exists as protium, tritium, and deuterium. Chlorine too exhibits isotopy. So we have isotopes for chlorine as well. We have chlorine 75 and we have chlorine 35 and we have chlorine 37. These are isotopes of chlorine. Carbon too has isotopes. We have carbon 12, we have carbon 14. We have carbon 12, we have carbon 14. So isotopes are elements with the same atomic number but different mass number. They are isotopes. We have some other phenomena in chemistry. We have allotropy, we have isomerism. Yes, we have isomerism. We also have isotopy. We have hygroscopy. We have efflorescence, and we have delete sequence. All these are different phenomena we have in chemistry. Now, the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. Is an expression of Boyle's law. It's an expression of Boyle's law. That is Boyle's law statement that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. At what temperature will the volume of a gas be zero according to Charles' law? At what temperature will the volume of a gas be zero according to Charles' law? What's your answer? I hope you are marking. I hope you are taking notes of your scores. Minus 273 Kelvin. Minus 273 Kelvin. At 0 Kelvin or minus 273 degrees C, the volume of the gas becomes equal to 0. The gas ceases to exist. A canister of gas has a volume of 400 milliliters at 20 degrees C. What volume will the gas occupy at 0 degrees C if the pressure remains constant? Let me give you a few seconds to work out your answer and let's see how it goes. Okay, so what did you get? The answer is 373 Kelvin. How did you get that? Let's see. This is a recall for Charles' law. Charles' law is V1 over T1 is equal to V2 over T2. And if you are going to fix in your parameters and see what it is, you realize that your this 400 ml is your V1 and your 20 degrees C is your T1 So we are looking for V2, and 0 degrees C will be 273 Kelvin. Also remember, don't forget that you need to convert this to Kelvin. So that's 273 plus 20. So in doing that, you make your V2 the subject of the formula. That means your V2 will be V1 over T2 over T1. Then you substitute your values. That's 400 times 273 over 293. And your final answer is 373. At 100 degrees C, what happens to the water? What happens to water at 100 degrees C? Does it boil? Does it freeze? Does it sublime? Or is all of the above? So the answer is it boils. Water boils at 100 degrees C. Water boils at 100 degrees C. The type of salt formed from strong acid and a strong base. The type of salt formed from a strong acid and a strong base is called dash. The answer is neutral. When strong acid and strong base reacts, the salt form is called neutral or called normal salt. But when you have a strong acid and a weak base, then it becomes acidic. Then when you have a weak acid and a strong base, then it becomes basic. Excuse me. Which of the following is the weakest attractive force that can be observed between two molecules? Which of the following is the weakest attractive forces that can be observed between two molecules? Which of them? The answer is van der Waals. The three of them are weak attractive forces. The three of them are weak attractive forces, but the weakest is van der Waals, while the strongest is hydrogen bonds. And they are all bonds or forces under covalent bonds. Hydrogen bonds, van der Waals force, dipole-dipole bonds are forces under covalent bonds. They are the van der Waals force or weak force of attraction. The one is the one that gives elements is it let us know if an element is going to be a gaseous substance or a liquid substance. So it's the weakest among them, and I said the strongest is hydrogen bond. What's the shape of s orbital? What's the shape of s orbital? Is it dumbbell, spherical, or triangular? The answer is spherical. S orbital shape is spherical. S is spherical, P is dumbbell. The three orbitals in a p subshell at right angle to one another and are designated PS, PY, and PZ. The transition of a substance directly from the solid phase to the gas phase without passing through the intermediate liquid phase is known as dash. That's a simple question. The transition of a substance directly from the solid phase to the gas phase without passing through the intermediate liquid phase is known as sublimation. That's the answer. That's easy. I expect every one of you to get that. Which of the following is a weak electrolyte? Yeah, which of the following is a weak electrolyte? Weak electrolyte has to do with weak acid, has to do with weak acid or weak base. If you look at it, every other one are strong. The HCl is a strong acid, sodium hydroxide is a strong base, and sodium chloride is a strong electrolyte. So the only weak electrolyte here is ethanoic acid, and ethanoic acid is a weak acid. Weak acid is when weak acids are acids that ionize partially. They ionize partially. So the answer is weak ethanoic acid. It's ethanoic acid. Yippee! We have come to the end of the class. So can you count how many points did you get? I think I should have like 40 questions. So how many did you get? I hope you've tried. I know you can do a whole lot more better. And I know you're improving in yourself. Good luck, and see you next time. Thank you. Bye.